Welcome back. Today we'll be doing day 5, which is all about pathway problems. So I'm going to actually start with the one on the right here because it's very similar to one that you had in your, I think it was your day 3 homework, where you're trying to get from one point to another. So let's say we're starting at A, we're ending at B, and we can only move to the right and down. So if we can only move, let's call this east and south. No matter which route we choose to take, we have to go east twice and we have to go south 4 times. So if you wrote this out using letters to represent east and south, so maybe E, E, S, 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 and then you were asked how many different ways could you arrange these letters, hopefully you would say, okay, well, order matters, so it's going to be a permutation. I have 6 different letters, but I have 2 E's which are repeating, as well as 2 4's which are, 4 S's that are repeating. So 6 factorial over 2 factorial, 4 factorial, and you could calculate this and get 15. So this is one way of solving a problem like this. Another way is to actually go into the grid and look at how many different ways there are of ending up at each intersection. And this is how it works. Let's say we look at A. Well, there's one way that we can start at A. That's it. And we're going to spread out from left and right. So to the right, how many different ways are there of getting to this point right here? Well, there's only one because I have to go straight from here to here. That's it. Same thing to this point right here on the left. There's only one way I can get to this intersection. But now, if I look at this intersection right here, there are actually 2 different ways that I can end up at this intersection, right? I can start at A, I can go east and south, or I could go south then east. So a point at every intersection is made, or the number of ways is found by adding up the number of ways of getting to each of the intersections above it. So right here, for example, I have one way of getting here, but this point right here, I have one way of getting it from the left and 2 ways of getting to it from above. So that gives me 3 total ways I have of getting to this point on the intersection. So again, you'll start to see quickly that going down each side here, there will only be one way because you just have to go straight. And then you can just start adding up the different possibilities. So 2 and 1 will give us 3. This intersection will be found by adding 3 and 3. This intersection will be found by adding 1 and 3. This one right here by adding 1 and 4. This one here by 4 and 6. And so the total number of ways of getting to B is adding up 5 and 10, which gives us 15. Notice that this 15 matches what we were able to find originally using a permutation. I'm going to save the Plinko example for a little while because I find that students find it tricky to see it when they're first learning how to do these. So let's try a couple of these examples down here. So if I'm looking at this one here on the left, you can see that this is actually made up of 2 types of questions which are the same as what I just did. So I'm going to actually just split this up into 2 for a sec. So if I was doing this question as a east-east, south-south question, okay, then the number of ways of getting from A to this point right here would be 4 factorial over 2 factorial, 2 factorial, because I have repeating E's, repeating S's. For the bigger rectangle, I have to go east 4 times, and I have to go south 3 times. So this is 7 factorial divided by 4 factorial, 4 repeating S's, 4 repeating E's, and 3 factorial for 3 repeating S's. So this is the number of ways I can get to here, and this is the number of ways I can get from here to here. So if I multiply, I get the grand total, which is 210. Let's try doing this again by counting out the different ways right on the grid. You'll notice that I'm writing on an angle. If you tilt your head a little bit to the left, you'll see that I'm actually looking at it more of as a triangle going down, actually kind of similar to this Plinko, instead of as a rectangle. So there's one way to get to each of these outside points. All right, I have to just go in a straight line. This middle point right here, this is 1 plus 1 is 2. This one is 2 and 1, which is 3. 1 and 2, which is 3. 3 and 3, which is 6. So now from here, where I have 6 different possibilities, there's 6 different possibilities of different ways of getting to this point, then there are only 6 different possibilities of getting all the way down to this point, right? Because I'd have to go in a straight line. There's not any more ways of getting to here. So that makes these all the same. Okay, so similar logic to why these are all 1. Okay, if you have a top number here and you're branching outwards like this, they're going to end up being the same number because you can't get to this point without going from here straight down. So 6 and 6 is 12. 6 and 12 is 18. 6 and 18 is 24. 18 and 18 is 36. 18 and 6 is 24. 24 and 6 is 30. 36 and 24 is 60. 24 and 36. So again here 60, 120, 90. And when I add 120 and 90 to get my final total, I get 210. Again, notice that this is the same answer I was able to get using just the permutation way of doing it. All right, let's try again. We'll do this one a little bit faster. This one, you'll notice, is different from the previous two that I just did because it's not made up of discrete rectangles. Like this first one was just one rectangle. The second one was 2 rectangles, but distinct rectangles. This one, because it's an odd shape, we have to do it by counting it out. So we cannot use this shortcut way. We must actually go and write it all out. So 1, 1, 1, 1, 1. 1 and 1 is 2. 1 and 2 is 3. 3. 3 and nothing coming from here. So this is 3. These will be 3. 3 and 3 is 6. 9 and 9. 12. 18. And again, if there are 9 ways of getting to here, there are only 9 ways of getting all the way down, because you must move to the right and down. Same thing going down the left will be 12. So 27, 30, 42, 57, 36, 45, 93, 99, 192, 138. So the grand total is 330 different ways.